Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson I'm going to implement the numbers that I used in the calculation of the PWM signal. I'm going to implement those in a computer program. So in a break from the norm, I already have the computer program written in, and I'm just going to write the comments in beside each of the different parts in order that you understand what I'm doing in each case. And that's simply because it's quite difficult to remember each of the different ones that you're going to have to include, because there's quite a lot here. So obviously when you get used to this sort of thing, it might be fine, but even then the chances of you leaving out one of these is considerably high. So do take careful note of each one of them as you go through. So I'm setting all of port B as an output. And strictly speaking, I don't need to set it all as outputs, but I'm not using any of them as inputs, so it's perfectly fine. As we said, either port B pin 0 or pin 3 will be used for the output of the PWM. And I did mention that the simulator seems to have a bit of an issue using it on port RB0, so or sorry, RB3. It's fine on RB0. So that's set in the configuration setting. I'll show you that later where to change it, but as I said, it doesn't seem to be operating in this particular version of the simulator. Now, I mentioned some of the things that we're going to have to set, so I'm just going to quickly, as I come through each one of these, I'm just going to show you where in the document I've taken that information from. So for one of the settings here, and just go back a little bit. You may remember here for PWM mode, in order to put it into PWM mode, I needed bits 3 and bits 2 to be set in order to put it into PWM mode. So that's those two ones there. And so I set those here, CCP1M3 and CCP1M2. I'm going to set both of those. So that's what I've done in the program. CCP1M3 and CCP1M2, they've both been set to 1. Okay, this is to put CCP into PWM mode. And I'm going to just copy that and put it beside this next one as well, so that we know that both of those are related to the same thing. Okay, now the PR2 value of 99 is one of the ones that I calculated for if I wanted to have a duty cycle of 100 microseconds. That gave me a value in PR2 of 99, and I went through the calculation of that in the previous lecture. So that's why I've put the value 99 in there into PR2. Now CCP1X and CCP1Y, those are the next two values. I've put them both to 0. In other words, I've cleared them to 0. Where did they come from? Well, further down here, here they are here, CCP1X and CCP1Y. They're for PWM mode. These bits 5 and 4 of this one, so they're that one and that one. These are the two least significant bits of the PWM duty cycle. The 8 most significant bits are found in CCP or 1L. Okay. Now, what we determined was that we were going to clear both of those to 0. If you remember here, that's those two zeros that I've shown there. Okay. I'm covering there. They're the two least significant bits. I'm just putting them straight to 0. Effectively what they do is they compensate for the fact that the T oscillator, which is, if I was using a 4 megahertz, that would come out at 1/4 of a microsecond. So if I put them both to 0, that brings it up to 1 microsecond. Okay. So, sorry, where is my... There we go, back to here. So that's why they're both set to 0. So just put in some of these. This is for a duty cycle of 100 microseconds, 4 megahertz crystal. I should say capital M there, otherwise for 4 megahertz oscillator. LSBs of, sorry, I said duty cycle here and I should have said period, PWM period. Because these ones, LSBs of duty cycle. there as well. And then the CCP R1L, I said I was going to put that to a value of 30. As you can see it down here, the value of 30 for that 8 bits. So that's what I'm going to do. So I'm going to change that from 10 to a 3. Now, we've 3 other things related to timer 2, which is that we're turning timer 2 on. It needs to be running. That's the TMR2 on. Okay, so this is actually, keep forgetting to write in my comments. So this is for a 30 microsecond on time. This turns timer 2 on, so that it starts running. And these 2 guys here are the prescalers for timer 2. And if we just find those there, let's see if we can find the timer 2 prescalers. So here are the timer 2 prescalers, 1, 4, and 16, as you can see there, but it's not telling us where we're going to do them. We're writing them into TCON, so I think it's further back up the document here. And here they are there. Okay, so T2CKPS 1 and 0. So if we're going to set them just to a prescaler value of 1, we need to clear them both to 0. So that's what I've set there. T2CKPS1 and T2CKPS0, they're both cleared to 0. So value of 1. Okay, so I'll save all of that, and I will run. Oh yeah, before I run it, just to show you, in the configuration bits we have set the CCPMX to RB3. I'm going to set that to RB0. And normally the way to do this, by the way, is to go to the configuration bits, and if you haven't got that, just go to the window, pick memory views and configuration bits. If you click on that, I already have it open. So configuration bits, this allows you to set individual bits in this, and it'll write the code for you. So you can see here where I've set CCP1 to RB3, I can set it to RB0, and then I can click generate the code for the output, and that generates the information that I want. I just copy it and I paste it into configuration bits. Paste it in over that. Okay, now I've already done it, so I'm not going to paste it in, but you could just select it all and paste over what you already have. Okay, so that's the configuration bits. As I said, in this version of the simulator, probably in the one you're using as well, it doesn't seem to have any effect. It still puts it out on RB0. I think that's just a simulator issue as opposed to where it would actually work on a piece of hardware. Right, so I'm going to run that program there. Okay, that's now running. I'm going to look at my logic analyzer. And we can see that we've got a signal coming out there on RB0. Again, you'll have to set up RB0 if you haven't now. I'm going to zoom very far in on this one so that we get a very accurate idea of the timing. One more time. Okay, now we can see here that in this case I'm starting at 1, 2, 3, 1, 4, 4, 0. Only worry about the 4, 4, 0 for the moment. In fact, the 4, 0 is the most interesting part. So what we see is that we start at 4, 0 and we go until, here's 6, 0, there's 8, 0, so this must be 7, 0. Okay, 70. So we're going from 40 to 70. That's 30 microseconds that we've moved, and we are staying at 0 for the next 70. So from 70 here to, in other words, 470 here to 540 here. Okay, so therefore we've got 30 microseconds of a high time and 70 microseconds of a low time. And just to take a little bit of a change in this, what I'm going to do is I'm going to change this from 30 down to 10. Now, we've seen previously that if you tried to get your duty cycle down that low, that you had issues getting below a certain point, and that was all to do with the fact that your interrupt was taking a certain amount of time in order to implement its own part, and therefore it wasn't doing the timings as accurately as we would have liked. No such problem with the PWM, because the PWM is done entirely in hardware. Okay, so we're down to 10 there. And again, I'm going to zoom a long way in on this so that we can get a very good look at it. You can already see that it's smaller than the previous time, but let's be very definite about our timings. So here we are at 040. This is 060, so that's clearly only 10 microseconds that we're set up for there. And then we are down for a full 90 microseconds. Okay, so 10 up and 90 microseconds down. Let's see if we can go for an even smaller value and see if it works. Okay, so we can see here this starts at 7740 and goes to 7760, and we're only using a quarter of it there, so we have exactly 5 microseconds there, and then we're staying down all the way from 7745 until 6. Is that an 8? It's actually an 8. It's just the size of the thing. I'll just make it a bit bigger so we can see it. So from 7745 up to 7840, which is another 95 of them. Zoom in one more time and see if it's easier to see. Okay, so we can see it there from 7740. That's going exactly 5 of them there. It's exactly halfway. And you'll notice that unlike in the previous case where you're doing it, it's not drifting off, adding a few instructions each time. It's very accurate with its timing. So PWM is very, very useful. It is important to realize though, I mean, you put it out either on RB0 or RB3. Now, if you put it out on RB0, do remember that RB0 is what you use for your external interrupt. So that's a bit of a nuisance then to have the PWM coming out on RB0. So normally in those cases you put it on RB3. Of course, it's not working in this version of the simulator, but it should work in most other cases. So do be aware that while we've got all this functionality, we do have to share it with other functionality, and you can't use all the functionality at one particular time. But this is a very good way of getting a very accurate timing, but you can only do one of them. You can't do it for several pins at the one time. Okay, and we'll leave it at that.